Alright, for each sequence, determine whether it's arithmetic, geometric, or neither. So if you can subtract these two and subtract these two, let's do that. So I'm going to do it on my calculator. 72 minus 96 is negative 24. 96 minus 128 is negative 32. So it's not subtraction. Let's divide. Okay, 70. This was subtracting. Dividing. 72 divided by 96 is 3/4. And then 96 divided by 128 is 3/4. Alright, again, since when we divide it, that's going to be our ratio, that's going to be multiplying. Since that's the same, it's going to be geometric. Okay, so what I'm going to do, since I know it's geometric, I know it's going to be exponential. Okay, I'm going to put 3 terms in, 128, 96, 72. I hit that, and I'm doing menu 41A because I know geometric is when it's multiplying each time, and multiplying each time is also exponential. So that's why I hit menu 41A, and you can see our equation here. Oh, once we hit enter, sorry, 1 second. Okay, let's hit enter. Okay, so 170.67 times 0.75 to the power of x. Okay, let's try this again. 300 minus 400 is 100. 150 minus 300 is negative 150. So subtraction did not work. Okay. Let's do division. Okay, 300 over 400 is 3/4. 150 over 300 is 1/2. So that didn't work either. So subtraction didn't match, division didn't match. This is neither, because neither of them are consistent each time. Okay? Alright, let's try subtracting again. Negative 2.75 minus negative 5. 2.25. Negative 0.5 minus negative 2.75. Look at that. Okay, when I subtract, I got the same difference. So it's a common difference, so that's going to be arithmetic. And if it's arithmetic, I'm going to put this information into menu 413. So nope. Negative 5, negative 2.75, negative 0.5, menu 41, and it's linear, so I'm going to hit 3. Okay, and I did that because arithmetic is linear. So I get y equals mx plus b for the linear equation, so it's 2.25x minus 7.25. Alright, well, these next ones, I wrote little notes off to the side, but it gives you the first term, 200. I need 4 terms, so the next couple terms, all I'm going to be doing is subtracting 15 each time. So that would be 185 minus 15 again would be 170, minus 15 again would be 155. All right, and then B, again, the first value is 12. Let's try that again, 12. And then what am I doing? 2/3 each time. So we do 12 times 2/3. 12 times 2/3. And I can hit enter again and again so I can get all of them, okay? So when I hit 2/3, I get 8. Then I get 16/3. And then I get 32/9. Now, if you hit Control Enter and get the decimal, that's fine too. Doesn't matter. Down here, if they just give you an equation, then you know you can graph Control T, right? Oh, and this was for B. But number 3, you can hit graph Control T on these. So let's do that. 243 1/3 x. So let's hit graph. All right, 243 1/3 x. Graph it, Control T, table it. There's my first 4 terms, 81, 27, 9, 3. Easy. Okay, if you have an equation, just graph it in Control T to get the table. Let's do it again for the next one. Graph it. And then what are we graphing? 32 minus 1.5x, 32 minus 1.5x. Graph it. Now 32 is way up top, so you don't see it, but still hit Control T. Here's your first 4 terms, 30.5, 29, 27.5, 26. Not too bad. Alright. Cool. Write a rule. Okay. Now remember, this is the first term, second term, third term, fourth term. Those are the terms. And the boxes, let's count them. On the first one, 1, 2, 3, 4. On the next one, 1, 2, 3, 4, 5, 6, 7, 8. On the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? So you might see the pattern that's happening each time. Okay, but we want to write a rule, so we're going to be able to put this into list and spreadsheet. Okay, again, the easiest way to get a rule or a function or an equation is just going into list and spreadsheet. You know the drill. We're going to be doing this all throughout this thing, right? And again, you only need 3, so let's do that. 4, 8, 12. Now before we can do this, we need to for sure know if this is linear or exponential. So let's find out. Let's subtract. 8 minus 4 is 4. 12 minus 8 is 4. Okay, by subtraction. So if the subtractions are the same, then that's going to be linear. Okay, if you divided these, you would not get the same number. Okay, 12/8 is like 1.5. 8/4 is 2. They're not the same. So since this is linear, I have to hit menu 4, 1, 3 because it was adding 4 each time, right? So x, y. So my equation is 4x plus 0. And you don't actually have to write 0, just y equals 4x. Okay? Cool. Alright. Next. Alright. Now on this one you can make 2 tables. It's too small. You got A, you got B, right? You got it. Okay, you got month 1 is January, month 2 is February, month 3 is March. 1, 2, 3. So on our A, receive $1 in January, $2 in February, and then $4 in March. Okay, and then on this one it's $20 in January, $25 in February, and $30 in March, right? So I'm looking at these. B starts higher at 20, right? But it's only adding 5 each time. But on the A, it starts at 1, but each time I can see it's doubling. 1 times 2 is 2. 2 times 2 is 4. Okay? So again, this is exponential, and this is linear. Alright? So how much will Evan's December allowance? December. Now what month is December? If 1 is January, 2 is February, December is going to be the 12th month, right? So, all we got to do is get these equations and check the 12th month, okay? Which is going to be better in the long run in the 12th month, right? So let's find out. Go to the spreadsheets. First one started with 1, double, double, right? Now again, since it's doubling, that's menu for 1a for exponential, x, y. Okay, I get 0.5 times 2 to the power of x. Okay, now for b, let's try that one. B started with 20, it was adding 5 each time. Menu 4, 1, and since we're adding each time, that's linear. Menu 4, 1, 3. Can't get those mixed up. So I get y equals 5x plus 15. Notice I didn't use y, I used a and b for the different formulas, okay? So we're going to look at each of these and see on the 12th month, okay? So the 12th month, what does A equal and what does B equal, okay? So we got these equations. We can either plug in 12 for x or we can look at the tables, okay? So 0.5 times 2 to the x, I'm going to go to graph. 0.5 times 2 to the power of x. Get the graph, Control T for table. I want to know the 12th month, which is December. $2,048. That's a lot of money. And now let's do 5x plus 15. Let's do the next one. Go to graph. 5x plus 15. Enter Control T for table. Let's look at that 12th month. 12th month, $75. That's a big difference. So we started off making a lot more money with B, and we end up not making a lot of money with B, making a lot more money with A. Okay? So plan A is better. Okay? Cool. So you should be able to take equations, take tables, get equations, plug in values, and compare them, right? All right, write an equation in y equals mx plus b form, okay? If you got a slope, that's your m. If you got a y-intercept, that's your b, okay? So it's easy. Y equals mx plus b. Okay, b is when x is 0. Not bad, okay? Okay, number 7 is more difficult because you got to use that point slope formula. Y minus y1, which is 7, equals m, negative 4/3 x, sorry, parentheses, x minus negative 3, so I'm going to put plus 3. All right. If I distribute that negative 4/3, I'm going to get negative 4/3 x, and then negative 4/3 times 3, negative 4, add 7, and I'm going to end up with y equals negative 4/3 x, negative 4 plus 7 is 3. Okay. And then the last one, now if I got 3 points, okay, I'm going to hit spreadsheets and get the equation, okay? Again, since we're writing it in mx plus b form, that's menu 413. Cool. Let's do that real quick. Again, given points, as long as you know if it's linear or exponential, spreadsheets is your friend. Okay, so now we got to actually put in these specific points. Negative 2, 4, and 20 are the x's. And then the y's are negative 10, negative 7, 1. Okay, menu 413, because it told us in mx plus b form, that's linear. Okay, so we get y equals 0.5x minus 9. Okay, number 9. For each table, determine whether it's linear, and if it is, write the function. Okay, so if it's linear, we subtract, we get the same numbers. 6 minus 9, negative 3. 3 minus 6, negative 3. 0, and then all the way down, negative 3, negative 3. Okay? So that's linear. All right. If we go into our graphing calculators, we do, again, same thing down here. Menu 413 for linear. Okay, I'm going to save us some time and let you know what it is. You're going to get y equals negative 3x plus 12. Okay. So this one is adding 1, adding 1, adding 1, adding 1. Okay. But I want you to notice on the left side, it's not going up by 1s, it's going up by 2s. Okay. So really, each time it's adding 0.5. Okay. But nonetheless, so be careful about when you plug this one into menu 413, okay, because the x values are not 0, 1, 2, or they're not even 1, 2, 3, they're 0, 2, 4, okay? So again, if you plug this in your calculator, you know what the rate of change is each time, okay? It's actually not 1, it's 1 over 2, okay? So again, use list and spreadsheet, you'll get 1/2, actually, list and spreadsheets will give you a decimal. So y equals 0.5x plus 3.2, okay? Again, lists and spreadsheets gives you the answer. Just be careful about the numbering here. Careful. Next one. Okay, so we're adding 4, then we're adding 4, then we're adding 8. Okay, and then we're adding 6. No, then we're adding 8 again. So again, you have to add the same thing each time. This is not linear. So this B was linear. Got the equation, not linear. Don't worry about the equation. It's not linear. Okay. Number 10. Okay, Jerome weighed 210 pounds when he started on a diet. He plans to lose 2.5 pounds per week. Complete the table below that represents Jerome's weight over time and write a function to represent the situation. So again, what's he doing? He's losing 2.5 per week. Okay, so he weighed 210 when he started, before any weeks, and he's going to be losing 2.5, minus 2.5 each time. Okay, so that's what? 207.5. Again, you can subtract that in your calculator. And then we're going to have 205, 202.5, 200. Okay? And write a function. So again, if you go into menu 413, just like the other ones, because these are linear, because we are subtracting or adding the same thing each time. Alright, so again, this stuff is subtracting. Alright, so since it's all the same, it's linear. So again, you go into list and spreadsheets, hit menu 413. You're going to get negative 2.5x plus 210. Okay? Cool. Let's go to the next one. Number 11. Okay? So now we're doing linear functions again. Alright, write a function rule to model this. Again, I think you can do this with menu 413. Alright, now, again, you kind of want to find out if the differences are all the same. Okay, I can tell you that they're not going to be the same for sure. Okay, so in this case, you want to put all the data into the list and spreadsheet. So let's do that. Alright, so let's go back. So we have 5, 6, 7, 8, 9, 10. Okay, so we got 480, 540, 605, 682, 754, 820. Okay, menu 4-1, and this, again, we know it's linear because of the section, okay, but also if we find these common differences, they're going to be pretty close together. So menu 4-1, 3, okay, x for x, y for y, and our r squared for this is very close to 1, so this is solid. So 69.11 is my m. X plus, and then my b is 128.48. Again, I'm rounding when I do this. What is the y-intercept from your function rule, and what does it mean? So y-intercept. So y-intercept is always initial value, and in this case, it's the initial what? So again, this is x, this is y. It's the initial weight of what? The kitten. Okay? What does the slope from your function rule? Okay. So the slope, 69.11, is the growth. In grams. By the way, this one was grams too. Grams per week. So it's growing at about 69.11 grams per week. Okay. And use your model to predict. Okay, so if we're predicting, we want to look for 22 weeks on a table. So we go back to the documents, we go to graph this time, and we're going to type this thing in, 69.11x plus 128.48. You're not going to see it when you hit enter, just hit Control T for table. Okay, we're looking for week 22. Okay, now if if you have a linear weight, okay, you have 1,648.9. And again, these are in grams, so it's not pounds. So obviously, this is more reasonable than it might seem. Okay, it's not 1,000 pounds. That's crazy. Okay, grams. So in what week will the kitten weigh approximately 1,300? So all we got to do is go back till we find 1,300. Approximately 1,300 means it's close. It's a close on week 17, right? So again, just looking at your table. Okay, again, what do? We hit graph and we hit Control T. Alright. Oh, leave that alone. Alright. Nope, leave that alone too. Thank you so much. And then scroll this down. Alright, exponential functions, whether it's exponential or not, okay? So how do we do that? We got to divide. So let's do that. We're going to take this divided by this. We're dividing, right? So 180 divided by 240, 3/4. 135 divided by 180, 3/4. And then 101.25 divided by 135. 0.75, which is 3/4. So this is exponential. The divisions are all the same. And you know what you can do? You can write the, it says write the common ratio and the function. Okay? So the common ratio is 3/4. That's what we're multiplying by each time. If you got 4/3, you're dividing it backwards. Please remember, it's this divided by this. The first divided by the zero term. The second divided by the first term, etc. Okay? So, last part, I need a function. Okay, so the equation, again, this stuff, since it's exponential, you're going to do menu for 1a. That's a 4, by the way. Menu for 1a. So I'm going to write it for you. I'm going to, again, you can do this, so I'm trusting you on that. So you're going to end up with 240 times 0.75 to the power of x. If you type it in correctly, okay? Let's divide these. 24 over 12 is 2. 36 over 24 is 3 over 2. Already, they don't match. It's not exponential. You can do the other ones if you want, but if 2 don't match, it's not exponential, okay? Again, we're going to divide these. 900 divided by 750. 6 over 5. 1080 divided by 900. 6 over 5. And then 1296 divided by 1080 is also 6 over 5. So that is exponential. The common ratio is 6 over 5. Again, type it into menu for 1a for exponential, and you're going to get, let's see here, oops, you should get 625 and then 1.2 to the x if you type it into menu for 1a. Alright. Cool. Next ones. In its first 4 years of operation, certain company increased revenue by 2.5%. Okay, hopefully you know that means 0.025. Multiply. Okay. Cool. So that's what's happening each year. Okay, when you divide 820 divided by 800, well, if you actually do it, you get something close to that. Oh, 1.025, duh. Cool. And then 840 divided by 820, control enter. See, 42 over 41, 1.825. Okay. So each time it's 1.025. So again, you can put that into list and spreadsheets, menu for 1a. Again, if you are multiplying, this is since you divided, this is a exponential function. If it's exponential, we do menu for 1a. And then what you would get is 800, 1.025, power of x. Okay? If this pattern continues, what would be the company's monthly revenue at the end of 1 year? So what we're looking for is 12. What is it, right? So let's type this equation into our calculator. To graph 800 times 1.025 to the power of x. Okay? I don't see it. Control T anyways. Let's find that let's find that 12th month. Alright. So we get 1075.91. There might be a typo in this table because on the second month, but we're going to just go with this. 1075.91. Okay. So the pattern, again, there might be a typo in there, but do your best using what you know. Okay. All right. You got a fresh pot of coffee, 3-minute intervals, talking about the temperature. Okay. So, does this data show growth or decay? Okay. So again, if it's starting at 180, it's going down to 140, that is decay, decreasing, exponentially. Write a now, exponential model, okay, is menu 41A in your list and spreadsheets, okay? Now, we're going to use X and Y, okay? So, X and Y. But just remember, each one of these X's is actually a 3-minute interval, okay? If you look at the number of minutes, they're going by threes. Okay, so let's go in here to list and spreadsheets. X, Y. Okay, and then we're going to type in 0, 1. And I'm going to type all of this in, okay? When it's a real world situation and it's not precisely multiplying by the same thing each time, more information is better. 180.2, 172.5, 163.8, 155.6, 147.9, 140.8. Okay, so again, since we're doing exponential, menu 41A. Okay, hit X, hit Y. My R squared is pretty close to 1, that's good, so my equation is going to be 180.75 times 0.95 to the power of x. Use your exponential model to determine the approximate temperature after 1/2 hour. Now, a half hour is 30 minutes. Now, we're not going to look for 30 on our x, because x is counting by 3. Minutes. So what would x be to get to 30 minutes? So x has to equal 10, because again, each x is 3 minutes, okay? Because 10 times 3 is 30 minutes, half an hour, okay? So let's take that equation, and we're going to look for when x is 10. So let's go to graph, and we're going to type this in. We just got 180.75 times 0.95 to the power of x. Control T. And we're going to look at 10, which is half an hour. It's 35. 0.59, and we're measuring temperature in degrees Fahrenheit. And then we'll go to the next page. Now we're talking about degrees again. Using that above, probably there and above. Okay, generate an exponential function. So again, we can get an exponential function by taking this, putting it into spreadsheets. Okay, so let's do that. We go into new document, don't save it, hit spreadsheets. Okay, X and Y, and let's type this stuff in. So we're doing 0 through 7. Okay. Cool. Menu 4.1a. Okay, because again, it's talking about giving the exponential function. So that's not 413, that's 4.1a. R squared, look at that. 0.999, that's really close. So, here we go. So we got 3.4 and 1.02. That 7 makes the 1 go up. 3.4, 1.02. Okay, so there's my exponential function, and we want to find a reasonable estimate for the population in the year 2015. If 2000 is 0, 2015 will be 15, right? So what would that be? Again, we take it over to graph. Okay, that's 3.4 times 1.02 to the power of x. And then we're going to hit Control T. Looking for the year 15 on here. All right, 4.58. Okay. So what will the population be? 4.58 million people, right? Of Harris County, Texas. All right, according to your model, in what year is the population expected to reach 5 million? So now you're looking for 5.0, or the closest thing to it. So between 19 and 20, right? So we'll say during the 19th year, during 2019. Remember, don't just put year 19, it's since 2000, so 2019. Multiple choice, yay! Auditorium has seating. Front row is 25, second row is 28, third row has 31. Okay. First row, second row, third row, 25 seats, 28 seats, 31 seats. What is happening each time here? If I subtract, I'm getting 3, and I'm getting 3. That's linear, right? How many seats will there be in the 12th row? Okay. So if I hit menu 4.1a, get my equation, sorry, 4.1.3 for linear, right? Get my equation, I'm going to end up with y equals 3x plus 22. Again, spreadsheet it, you get 3x plus 22, and I'm looking for the 12th row. So if I go into graph, hit table, okay, I'm going to get 58. Okay. So again, get the equation, graph, Control T. Cool. T-shirt company charged $20, set a fee plus $8.95 for each shirt. Okay. Does this situation represent a linear relationship? Well, if it's 89 for each, that's adding $8.95 each time. Yeah, your equation would be 8.95x. That's what you're adding each time, plus the startup fee, which was $20. Okay, that is linear. Okay. So it's not linear. It is, yes, linear. Okay. And by the way, you can rewrite this the other way around. 20 plus 8.95x or 8.95 t is fine. Same thing, okay? Alright, so 20, not 20t, not 20t. 20 plus 8.95t. Cool. Let's finish this thing off. Okay, when you're doing best model on a graph, you want something that cuts it down the middle. A, too low. Okay. D, too high. Okay. Now B or C, which one cuts it down the middle? Now B has 5 below, 2 above. Okay. It's not even. Okay, but C cuts it more so down the middle. Okay. Because it's cutting that one in half, cutting that one in half. Got 3 above, 2 below. It's more evenly cut in half. Cool. Oh, don't move that. Moving this down. Cool. 31. Look at the table below. Which of the following statements is not true? Now, first of all, let's subtract. 80 minus 64 is 16. 100 minus 80 is 20. Okay. This is 25. Those aren't the same. Okay, if we were to divide them, let's see if that would give us anything. 80 divided by 64. 100 divided by 80. So if we divide, we get 5 over, whoops. We get 5 over 4, and we get 5 over 4. And then 125 over 100, we get 5 over 4. So this is exponential. Okay, so the function is exponential. That is correct. If I put this into my calculator and I hit menu 41A, then I would get y equals 64, 1.25 to the power of x. So that's right. Common ratio that I'm multiplying each time is 5 over 4. 5 over 4 equals 1.25. So yeah, that's good too. This says it's decay, but it's going up. Decay is wrong, okay? Which one was not true? Decay. It is supposed to be growth. Okay. Last one. Which of the following functions best models the given data? Okay. So let's do menu 413, and then we'll do menu 41A. Okay. So I'm going to type in all the data, see which one gives me a better R squared. Okay. Oh. Oh. Zero through 6. Okay, so we got 12.2, 18.5. You could find all the common differences and all the common ratios and see which ones are closer together. That's fine. Here's another way. Okay, menu 4, 1. I'm going to try 3 first, okay? Now my R squared is 0.896, which makes it 0.9. 0.90. Now, if you go right here, you don't have to retype it in. Just hit menu 41A. X is X, Y is Y. Hit OK one last time. R squared is 0.99977. R squared is rounds to equal 1. Now, which one's closer to 1? Hey! So that's exponential, right? So if it's exponential, that's the one I want to use. What's the equation for exponential? 12.16 and 1.5. 12.16 rounds to 2. 1.5 power of x. And that is closest to this. Okay? So it's all the stuff we've learned applied. All right?